Hi, very good morning, all. Welcome to Performance Engineering Training Program. I am Radha Krishna Prasad, and I have around 13 plus years of experience in performance testing, performance engineering, site reliability engineering, observability practices, and all of that. Like every one of you, I have started my career into performance testing right from the day one, slowly transformed that into performance engineering by adding all the emerging tech stack depending upon the market task and various business requirements that we have from multiple organizations, be it service based or service or product based. So I am here to teach you performance engineering within 22 days. Okay. And I'm going to tell you what are all the concepts or what are all the concepts, theoretical and practical things that we are covering as part of this training program. Initially, you may feel little confusing, but after completing uh, course demo and technical demo, you will get more insights on what is this course is all about, how you are going to get uh, a value added benefit to your current existing experience or training uh, skills that you have. Okay, and coming to uh, my introduction, I think most of you have already know me because I have given so many open sessions on Performatrix, and we have trained many people in performance engineering aspects and performance testing, monitoring tools, and all of that. Now, if you ask me, uh, who is this course actually? I mean, what are the participants who can do this course? If you can see this current slide, this particular course is basically for performance testing engineers, mainly people who are doing the same traditional performance testing or CI/CD performance testing, having experience and knowledge with JMeter, Load Runner, then Neoload, some newly added tools, right? Some unique skills like K6, Locust, or you have some other tools that are being connected in the pipeline, then you are automating some reports, all of that. So this course is mainly for performance test engineers who want to really transform their career into performance engineering. And for developers, because we are taking something like code profiling into performance testing, in this performance engineering course, because you need to know what are all the problems, hotspots with the spaghetti code, inefficient code, right? 80% of the bottlenecks happen from 20% of the inefficient code. So developers, performance architects, uh, then solution architects, DevOps engineers, SRE engineers, anyone who is passionate about performance engineering or who is interested in performance engineering, right? This course is for them. And I totally understand that performance engineering is so big, the learning curve is so big because uh, different companies across different organizations are asking different tech stack, right? Some people can ask you Docker, Kubernetes, different clouds like AWS, GCP, or Azure, and you also have different monitoring tools that have come into place like Datadog, New Relic, Prometheus, Grafana, AppD, Dynatrace. And coming to the type of application that you're using, be it Java, be it .NET, or you have different things. Let's say you have React as a front end, you have REST APIs, you have messaging queues. So for all of that, as a performance engineer, you need to know what is the percentage of concept that you need to adopt, that you need to learn when you're doing performance engineering, especially when coming to identifying the performance bottlenecks. Again, the one point that you need to understand here is it is not that only just the performance engineer is taking care of all these things. By collaborating proactively with all other teams, at the end point, there is one situation where you need to derive a conclusion saying that this problem or this performance degradation is happening for this reason. For that, in that aspect, right, we need to uh, look at the application in 360 degrees view. So I'll tell you how to do that. And now, if you have a question like out of this 22 days program, what is that I will learn? What skills I'll get? So you will try to get most of you, right? Still, if you go to interviews or something, you have the same question, or the discussion is going to happen only on the requirements phase, or workload modeling phase, or you have capacity planning, or some people are asking you system dynamics, right? So how do you understand the application in many ways? Most importantly, right, you need to understand the gap, and when you get some requirement. For example, you say that people say that payment gateway outage on a festival sale day. That is the only requirement from one of the customer. So how do you initiate it, or how do you start? From how do you derive it? And you need to understand what gap analysis you have to define. So here, right, uh, if you understand the scenario that I'm explaining now, only performance testing was done to many of the applications, right? So you cannot say that after doing some performance testing on a specific test environment, which is not same as prod, and defining a report saying that this application is meeting this SLA with this many number of users. How are you comparing these results with the actual production, and all of that will teach you in performance engineering gap analysis. We'll teach you how to design a production grade SLAs, what SLAs are being met in a test environment, and what you're not able to meet in a production environment, the actual application. And most importantly, we need to work on the root cause analysis, right? So the root cause analysis, the recommendation or the solution for a specific bottleneck that you write as a performance engineer in the report, you need to write it as an evidence based, or you need to have some dashboards with some metrics, with some numbers, right? To make the customer to understand this is the problem when I have done some so and so testing, be it load testing or spike testing or whatever. Okay, so this is root cause analysis, where we'll be talking about many incidents, many real-time scenarios, case studies, okay, to give you more insights. And not only that, we are primarily focusing on this program because many of the applications are still legacy applications. You need to understand some operational level, system level, client level, server level. And as you see, if you take the applications, right, be it Bank of America or many banking and financial applications, Wells Fargo or JPMC, SunTrust Bank, all these banks, right, still they rely on the legacy systems, the old versions of JVM. I'm talking about Java JDK 8. There are Java JDK 11, JDK 17, all of that. So here, what we are primarily focusing is we are focusing on JVM tuning, JVM advanced tuning to fine tune the Java applications and the .NET applications, and most importantly, the databases. So when I say the databases, you have SQL databases, NoSQL databases, you have a lot of that. And coming to other applications, right? Depending upon what applications you have that is developed in Java or that is developed in .NET, your database would differ. For example, if you have a .NET applications, right, it is hosted on IAS, right? IAS Web Application Server. You have to deploy the application there. You have Microsoft product is .NET. Then your web application server is from Microsoft, which is Internet Information Services 10, where you need to deploy your source code that is written and developed in Visual Studio, which is a Microsoft product again. And you are connecting it to the Microsoft database, which is SQL Server, right? So the entire chain belongs to Microsoft. That is one tech stack. So you can connect to other open source databases. It is not that you are using only that. For Java applications, you have many options. The application that is developed in Java, right? You have Apache Tomcat, which is an open source web application server. Then you have IBM WebSphere. Then you have Oracle WebLogic. Then you have different web application servers connected to different databases. You can connect it to Oracle, you can connect it to MySQL database, or you can connect it to Postgres, which is an open source one. So we are going to talk about all of that from different operating systems, different JVM versions, and .NET application servers, .NET performance problems, and database performance problems. And I don't want to disclose the names of the monitoring tools that I'm covering here now, but I'll show you how to install an agent on a web application server or a database server, how to bring that metrics, how to see that numbers, and how to interpret those results is what we'll teach you here. Okay. So the slides, maybe don't follow the slides. I mean, I would like to make make you understand on what you'll finally get. Okay. So you may have so many things on the PPT slides. It's not that we don't cover or we cover, but whatever we have mentioned in the PPT, we will definitely cover, right? So don't get confused with that. I'll take up the questions in the last. And any question you have, anything that you want to ask, feel free to ask at the end of the session. And like we said, right, our mission from the performance engineering course was to transform, help everybody who is still stuck in performance testing, I would say. I'm not saying that it is traditional performance testing or a skill based performance testing. So when I say performance testing, right, you have some tool, you have some NFRs, you have some test plan, you're working in a agile sprint based methodology program, you're taking up so many sprints, you're running couple of tests at the end of the sprints, then taking backlogs and publishing the results, and you have a simple comparison. If this is the use case, or if this is the program that you are still into with your some 10 years or experience or 12 years experience, our mission is to help you to teach the entire performance engineering life cycle with the complete end-to-end project full life cycle implementation. So every phase from the PTLC or the performance engineering process, or from the capacity planning process, or workload modeling, when you have limited parameters, how to take your assignment from there, okay, in the defined timeline by creating a risk assumptions, mitigation strategy, all of that we will teach here, and we will make you industry ready, especially interview ready. Okay, there are too many things that are asked from the performance testing and engineering point of view, so don't worry about that. uh, what you have from your side and what we teach from our side will give you a good picture on what you have to portray, especially when you are giving some interviews with some X years of experience. Okay. Now, coming to the course content, I have written something like Introduction to Performance Engineering. This is we talk on the day one. Why performance engineers and understanding the differences between performance testing, performance engineering. So I'll also tell you how SRE came into picture. Okay, how observability is being added to the performance engineer skill set, and most importantly, why performance engineering is critical, right? You when you test an application, it's not that you reveal the performance degradations of an application from the client side or the server side, or from the infra side, or from the technology side, code side, server side, operational level side. No, it is not. So you need to understand, this is when we talk about performance engineering, the criticality of this phase, right? So each phase has some working nature. In the entire use case, when you send a request, when you get a response, right? In this use case traversal, when the request goes from the client to the server, you need to understand what is the user critical path, right? UCP. So when you send a request, it goes to the router, then the firewall has to authenticate something. Okay, you have inbound rules, outbound rules there, which you need to set. Then it has to go to a load balancer. You have a software load balancer, hardware load balancer. Then it has to go to the web server farm, where it has to go to the web server, app server, database server. Again, here it depends on what technology the application has been built on. You may have Kafka, you may have API gateways, you may have proxy servers. You may have file servers, and your databases can be distributed, cluster databases. So, what are all the technologies that are involved? What are all the components that are involved? For example, to make you understand, if you take a big comparison of the performance testing environment where you're actually testing and production environment, right? Uh, you may not have the existence of CDN, right? You may ask me what is CDN. We'll talk about that. Then you have something called DNS, domain name server. And there are some couple of tests that you're doing with cache enabled and cache disabled. You'll have numbers, difference in numbers where you need to compare that. And you may not have the exact volume of data in your database, what you currently have in production. So there are too many things here where you need to understand the existence, the work nature of that component of the technology, and how performance engineering is helping to identify all the different bottlenecks at various places in the entire performance engineering is what we'll teach you. Okay. And coming to the roles and responsibilities, it would differ depending upon the the requirements, the company, the product task, the project task. It would differ. Okay. Many of the performance engineers now, many companies are expecting them to clear something like a hacker rank or code pair round as a first initial round, because the top companies typical expectation is to check the performance engineer if he is capable of understanding the logic, understanding the code, or understanding some of the hotspots in the code that is provided in the hacker rank round. So it depends on what roles and responsibilities you will have. In interviews, you may get so many questions that are asked from various teams, from various people with their experience. But what I heard from many people is they are still doing the same performance testing, scripting, correlations, and all of that after joining the company. Okay, so that depends. So I'll also tell you what is the career path, and the uniqueness of this program is we'll teach you how the real world case studies will work. Okay, we'll also give you one lab assignment. We'll make you understand how you can deploy a sample application on a web application server, how you can create data using a fake data generator, and how you can upload that into the database. So all of that, we will help you to make your own lab setup ready so that you can install that on your own personal laptop with good configuration, minimum with i5, 512 GB and 16 GB RAM. So when you have something like that, we will make you install some application with some web application and database server. And if you have more hardware on your application, I mean, on your laptop, you can also run simple tests. You can work with some free trial versions of New Relic or Datadog. You can install agents on the web application server. You can go inside the code when you're running a test with 25 or 30 users or max 50 users, because your personal laptops, they don't support beyond that load. Okay. So when you do that, right, you should be able to do your own hands-on exercises. We'll tell you how to do that. And like I said, I mean, every day, right, that we are talking, we are giving a real-world case study, and we'll also give you the lab assignment. For example, here, the first slide, we are only talking about the what is it? Introduction to performance engineering, right? So, can anybody tell me what case study you can think of? Let's say I'm telling you that there is a payment gateway outage on a festival sale day. Even if you have seen, right, there is a Republic sale day on Flipkart and Amazon. You have a simple Indian e-commerce. platform during Jan 26th, which is Republic Day. And you are saying what? Mm, Load testing has been completed and it is passed. That is what you are sending or publishing it to the customer. Now, if I'm talking about the problem of this particular case study, when the sale was announced, the first day, the sale was announced at 6 p.m. At 9:05 p.m., all the payments from a specific region in India, let's say Hyderabad, payments started timing out, which means that users are not able to place the orders or are not able to proceed with the order confirmation. They're trying to make the payment, but they are failing it. So orders failed despite many servers that you have running at what 40 to 50% CPU. You think that this is not the bottleneck. Payments are failing, orders are failing. All the servers are running at 40 to 50% CPU. Now, if I ask you what went wrong, can anybody tell me what went wrong? It's only a prediction or an assumption that you can make. Any answer is okay. What went wrong?
Maybe it's not issue from Amazon or Flipkart, but they are also the payment is also depend on Visa and Mastercard applications as well, right? They are third party payment gateways,
Right.
so that's one of them. And also, you told like six o'clock the deal started and it happened sometime around 9, so it's more than the normal peak volume we can expect during that time, and it is more than load test time, like it's like more than 3 hours. It's like uh, s- there are chances of getting a memory leak. Um, that's
Right.
uh,
So, excellent. So, like I said, right, only performance testing was done. It was a happy path. So that is what people want to see. No one wants to go ahead and touch something like a legacy code or understand what happened. Now, let me tell you, when I say what went wrong, right? The capacity modeling, like someone said just now, it could be some peak traffic. You need to understand the production traffic analysis. You need to have a math on what is the maximum amount of load that you can expect during the sale time, and you have to prepare your application. You have to do some readiness testing to handle that traffic. And there could be some of the failure scenarios that you have to plan well in advance, and you have to work on that to see where your system is breaking. For this instant, right, your database connection pool can be capped at 100, your value is 100, but your peak concurrency on the application is 3000, right? Then the orders will stop failing. If you want to detect that, like when you use your monitoring tool, right? You go to the database server, and when you see, right, whatever the APM tool that you're using, it will show you long waits on DB connections. That is an evidence based. Okay. You will have hundreds of metrics on different entities, different components, different technologies, everything that you need to configure. When you see something in red with a metric on a specific instance, be it application server, database servers, or a node or a pod or anything, right? Your APM is showing long waits on DB connections. Then I suspect my database connection pool. I do the same thing on my thread pool. I watch my thread pool. I'll take a thread dumps, and if I see something there, too many blocked threads, then there is a problem there. Again, I'm telling you what, uh, sir, this fix can be I'm increasing the connection pool, then I'm introducing something like asynchronous payment confirmation, then I'm adding rate limiting, all of that. It may definitely give you a fix, but the main point here, what you need to understand is how performance has been improved. Many people say that we are moving from monolithic to cloud, monolithic to microservices, right? Then you are moving to on-premise to cloud. Why you are moving to on-premise to cloud? Sir, because we can scale up. Will not have outages. You have auto scaling feature enabled. We can auto scale everything. With the help of auto scaling, you can increase the availability, you can avoid failures, but you cannot improvise the performance of a specific transaction. You cannot bring a specific transaction when you have more number of users, more number of requests, more number of transactions happening. You cannot make something to come and improve the performance. We have to do some changes to the code, to the infra, to the environment, to the configuration settings to bring your performance SLA from 9 seconds to 4 seconds. That is where we are learning performance engineering. Okay. And coming to I have given you one case study for your understanding. We'll talk a lot about that. And coming to the day two, right, we'll talk about the SLAs, common performance issues. Again, like I said, you can see a lot of things on my slide. But let me tell you, your SLAs, right? Most of the applications, you don't have anything in your hand. Your customer wants you to convert everything into requirements. He may give you one specific thing, right? But you have to define it everything from there. Am I right? So let's say you have to achieve 0.6 TPS. Then you have to derive the test duration, you have to derive the number of users, then you have to derive what type of tests that you have to do, all of that, right? So requirements you may have in different ways. When you see the specific slide, let me tell you one example. Your SLAs are passing in test environment and 80% of them are failing in production. So uh, at the end of this thing, right, people come back to you and ask, mostly customers, stakeholders, or end users who are using the application. You said login or such transaction is giving you less than 3 seconds, but I could see 6 seconds, 9 seconds, sometimes 13 seconds in the night time. So why is it happening on my production application? So even if you talk about the SLA of many banking applications, right, 90% of the transactions are less than 2 seconds. The problem now is your test environment is meeting SLA. The production users are complaining of 6 to 8 seconds. There is a delay. So again, to understand this root cause, right? Now again, you have to compare, understand the gap between the performance testing environment where you are doing all the tests and the production environment what you have. In the performance testing environment, you will have a clean DB. You will not have anything. You will not have batch jobs running. You will not have systems up. You will not have the same volume of data that you have in production. No. Whenever you're doing performance testing on a performance testing environment with 100 users or 1000 users, only then your database CPU, memory, disk, and network are completely utilized. The rest of the time, as it has no data as production, it is not the mirror image of production. During idle time of the performance testing environment database, you're having 15% CPU, 9% memory, IO is also good, network is also good, no latency, right? So here I am going to teach you how to define an SLA without peak background load, how to identify the peak SLA consideration, off-peak SLA consideration, and every time, right, when you are doing performance testing, you need to have a separate SLAs for business hours, batch jobs, databases, batch job throttling, because I have come across on something where I need to measure the performance of the database for a batch job that is running for 6 hours from now. I need to measure the performance of my database. How this particular batch job really went well. What are all the delays or degradations that happened? What are the response times? So what is the volume of data that has been injected? What are the resource utilizations? All of that I need to see. Okay. So that way, we will learn from this slide SLAs without context, right? You cannot do anything. You cannot, whatever you are doing from a performance testing point of time, it will go, it will go waste. So coming to the test data and production traffic analysis, how data is important, how to create the data. So like I said, you have test data evenly distributed or 70% of the data. Let's say if you're doing performance testing for an application like Airtel or Vodafone or any this thing, telecom recharge platform, load tests are getting passed, but production is getting crashed, right? When a new plan is launched, production when users are accessing, it is actually getting crashed. So for that, you have so many different reasons, like you'll have dummy data, you will have test data that is not evenly distributed. Or when you're doing performance testing, right, you're focusing only on specific plans. For example, 70% of the workload is only distributed on the top three plans. You have a new plan that is added. When you have a new plan that is added, that is not taken into consideration, you didn't plan a scenario for that. So here you are having so many DB wait events or hot partitions identified from the database. You have row level locking, all of that. You can monitor all of that in parallel to identify what is the problem, and it is going to tell you where is the problem. Okay, so I'll tell you how to analyze the production traffic. If you take the historical data, I'll explain you how to do that workload conversion from the production logs on from the web server logs. I'll tell you how to create the test data, what is the strategy, how to create the data if it is unique. For example, if you're using 4 lakh credit card numbers in a specific test where every field is unique, right? Which means that you can use that credit card number only once in one iteration. You cannot use it for the second time. If you are using sequential each iteration, continue with the last value in load runner option or continue in a cyclic manner, it is going to take the last value to simulate that last value in the test. So what happens here is you cannot do that if you are using a unique data. So when you are using a unique data, I'll also tell you how to create the data, how to upload the data, how to get the data access path from database, and I'll give you a case study on data-driven performance failure. Okay, we'll also have a lab assignment. Okay, and like I said, in the day four, we'll talk about performance test results analysis. I'll tell you what are all the metrics that you need to see, especially client side, server side metrics, and most of the things, right? Most of the basics are missing. What I feel is most of the basics are missing. So when you get the initial report from the load runner or JMeter, how you compare response time with throughput, throughput with error rate, response time with hits per second, then response time with the CPU or memory or disk with the application servers or database servers in this thing to get some initial insights. So there is some good interpretation on the client side metrics, average response time, error rate, throughput, okay, hits per second, all of that. We'll talk about the saturation point concepts. We'll correlate, compare metrics, and I'll tell you how to get into some conclusion on what went wrong with the initial report. This particular scenario is mostly for the people who don't have monitoring tool in place. Most of the people, the startups and other companies who don't really spend on the application performance testing. So what they do is go with some open source monitoring tool or use Perfmon or use Nmon, use Windows Event Viewer to understand the problems. Because in Perfmon, right, you can create a custom counter set, right, by adding all the metrics, and you can take 80% of the numbers on what is happening on or what happened during the test. So I'll also tell you reasons for high CP utilization, low CP utilization, bottlenecks identifying approach, and I'll also give you some case studies. There are multiple case studies. Don't worry about that. Even if you don't get good understanding on what the case study that I have mentioned here in every day-wise slide, don't worry about that. I'll take it forward from there with many case studies. So I'll also give you some good homework. As you have so much of privilege to work with the different AI tools, or you can ask anything to any AI tool, right? So you will get lot of information, lot of step-by-step exercises, but make sure that you are doing some kind of fact check. Okay, you may get a case study, you may get a step-by-step approach, but you need to check the feasibility of whether this issue can happen or not. So after the recent adoption of AI, so most of the people, right, they don't do fact check. You get some question, you get some context, you get some problem statement, you get some step-by-step approach, fix, and you get the final outcome. So the level of human interpretation that you're doing with AI is what is important here. Okay, everything that you see on the internet, everything that you see on the AI tool is, I'm not saying that it is not true, but as a human being or as a typical performance engineer, when you get something from the tool, when you get some report from the load runner, you get some ADDM report from the Oracle database, you get ASH report, active session history report, automatic database diagnostic monitor report. These are all automated reports. You get a problem, you get an assumption, you will get a fix. But here, we are, as a performance engineers, we are collaborating with the database administrators. We are identifying the problem. We are mathematically looking at different values and trying to understand what value increased with what. And that is where you are writing the right conclusion or a specific recommended fix. And you'll also, when you write a symptom, when you write the proof, when you write the fix, and you also need to highlight what value add has been achieved here. Throughput collapse stopped. Throughput didn't go flat, or throughput didn't drop, or throughput is not continuously growing. Okay, so I'll tell you the reports how to interpret, and like I said, right, most of the Java applications, primarily when I'm talking about the JVM, excessive memory utilization, excessive resources utilizations. Like when I say resources, it is CPU, memory, disk, and I network. When I talk about memory, right, JVM, any application is all about memory. You're talking about heap, you're talking about stack. Again, inside your heap, you have young generation, old generation. Then you have, what is that? In young generation, what you have? Hidden space, survivor space, and again in survivor space, you have survivor 0, survivor 1, then you have old generation. This is all heap. Then other than that, on top of it, you also have permgen till till Java JDK 7. From Java JDK 8, the permanent generation is now replaced by something like metaspace, and it has got so many advantages. Okay, we'll talk about memory leaks, out of memory errors, excessive memory utilization. Here we are going to talk about object allocation rate, premature promotions, minor GC, major GC, full GC. Okay, heap after minor GC, heap before major GC, GC past time, stop the world events. All these things are not terminologies. They are huge concepts when it comes to performance engineering. We need to understand how memory is being utilized. What are the different problems that we are getting? What are the different situations, scenarios? Okay. To identify all of that, we are taking multiple heat dumps here, right? Only when I talk about heap is only talking about the memory. It's not the total available amount of memory. It is talking about the JVM specific memory. Okay, I'm talking about an application server. You have a JVM inside that, and out of available physical memory that you have, let's say 128 GB on your application server, what amount of memory that you have to define as an initial heap and maximum heap? Sorry, is it a 50% of the available memory, or is it uh, one fourth of available memory, or 1/16th of available memory? There are so many mathematical derivations on that. I'll tell you how to decide and all of that. And the same way I'm talking about thread dumps, because if your application is having resource contention, if your application is having deadlocks, if your application is unresponsive, application server is continuously crashing, you have to take multiple thread dumps to understand which thread is blocked, which thread is waiting, which thread is continuously running. So all of that we'll try to identify by using different Java monitoring tools like, I mean, I'm talking about the code profiling context here, JMC, JProfiler, okay, then your kit profiler, you have JConsole, JVisual VM, Visual GC, a lot of things are there. So we are going to take a deep dive on that, and I'll also give you some good assignments and all of that. And coming to the performance testing environment, right? I'll tell you in a single one line, I'll tell you how to create a performance model right from the scratch, which means that, I'm sorry, let's say that your current application capacity is, production application capacity is 1 lakh users per month. And if you have to test with 10,000 users, now you have to define an environment where you can test with 10,000 users. Most of the performance testing assignments, they fail because of performance environment that you are creating in the architecture. Because what are all the tech stack or what are all the components that you're using in performance testing environment, most of them will go missing when you compare it with production. Like I said, today you go and see in your own assignment, today you go back and see the performance testing environment. You'll not have DNS, you'll not have CDN, you'll not have load balancers, you'll not have caching enabled, right? Caching has some algorithms. You have browser level caching, server level caching, component level caching, lot of things are there. Not everything is simulated. You don't have caching at all. Load balancer, you have two different things that are separated. One is software load balancer and hardware load balancer. And each load balancer has got algorithms. Let's say round robin or least weighted connections or hash map. Each load balancing algorithm has its own way of distributing the load, right? So here, as a performance engineer, some at times, right, you need to tell them that okay, for testing uh, eight one 10,000 users, right? If your production application, if your production server is 8 node application, you have RAID replicas, you have CDN. Uh, in test, right? In testing environment, it is 1/10 of production volume what you are actually testing. Out of 1 lakh users, you are using it for 10,000. You are using or testing it for 10,000 users. Now you are telling it's a straight mathematical formula like 1 lakh users, then 10,000 users. It is 1/10 of what you have in production environment. So this is like you have a case study. Will not go much deeper because in this case study, right, I'll tell you the environment mismatch disaster. Okay, don't go with big bottlenecks as of now. If your requirements are not clear, if you're going with the wrong requirements, if you defined incorrect SLAs, whatever you are doing for 6 months is a waste of time. If your workload modeling is wrong, if your production traffic analysis is wrong, If your capacity modeling is wrong, if your scaling is wrong, whatever the results that you get at the end of the project are not accurate. You cannot derive conclusions, or uh, you cannot get into some conclusions on what went wrong, why, for what reason all these things are happening. Okay, so for all of that, you need to find out, understand the importance of why environment parity matters. Okay, I'll tell you a detailed case study on environment mismatch. And coming to the other slides, right? Memory management, then if you see this particular slide from the Java applications JVM management, you need to know JVM architectural internals, okay? How does a JVM work? When you give some code to the application server, right? The basic things, how to deploy an application, when an application is deployed in an application server, how this JVM is taking responsibility to execute that source code, how a deployment will happen. So if you have multiple changes on the same code, how multiple deployments are going to happen. You need to know some basics of Git. Okay, we are not teaching that anyhow, but I'm just telling you, you need to know some basics of Git. Then you need to know something like TeamCity or all of that. And when I'm talking about the architectural internals of JVM, right? Each of the JVM version has its own features. Okay, till Java JDK 8, it is different from Java JDK 11, Java JDK 7. Different things that are happening. Allow me a minute. I'm sorry, I'll just mute all. Sorry for that. So in Java, there is in Java JVM, right, which is an execution engine of the source code that we actually deploy. You have JIT compiler, which is also a primary bottleneck. Uh, JIT time, percentage of JIT. There is a metric for every JVM to understand how the performance is JIT is doing, just in time compiler. JIT. So, and also the garbage collection, which is unused memory impacting JVM efficiency. Here we are going to talk about uh, different GC cycles that are running. When you take a, heap dump or when you analyze a GC, right, it is going to talk about minor GC, major GC, and full GC. So each of the GC that is running, right, it is going to show you minimum pass, maximum pass, and average pass. There are utilities for that to identify which GC ID is actually the problem. There are different GC IDs that are going to tell you which are problematic, so that you can go with the specific timestamp, and you can analyze the GC log, and you can tell whether the problem is from the GC or from the heat dump or from the thread dump or from different application servers. Okay, and also coming to the workload modeling, the basics, right? Uh, if you see the workload modeling, many of the people, they come back and ask me how to do workload modeling from scratch. Okay, when I say workload modeling, right, this is where we are spending some time. I have decided to spend some time on how to do workload modeling, when to do workload modeling. So when to do workload modeling, understanding concurrency, arrival rate. So when we talk about a specific workload, right, there are two different things. One is a business workload and one is infrastructure workload. So I'll explain the clear context and difference of the business and infrastructure workloads here. Some business metrics in workload model, how to do that. And I also assume that many of you don't know what queuing models are, how queuing models are going to help you in defining a workload model. And considering the growth and season, the peak traffic, off peak traffic, right? We'll also talk about how to do that. And especially here, right? I'm also planning to give more than two or three case studies with two lab assignments to get the clear understanding on how workload modeling will happen. Okay. So when I say this, theoretically, you may get so much of different insights. But when we talk about some case study, Black Friday traffic explosion is one of the very good example to understand the workload model. Okay, because the normal traffic versus peak traffic. The normal days you may have some 2x traffic, but on the Black Friday sale, it can also go up to 60x traffic or 80x traffic. You can't even imagine what is the rate at which the workload is growing. And when you do workload modeling, the common mistake that you do is you're using only concurrent users. We will ignore the arrival rate spikes, which means that all of a sudden you get some thousands of users coming into the application. You see a sudden spike on an unexpected transaction where you will not be able to handle it, right? You are giving some low priority of a specific transaction. That specific transaction is having some 6x traffic than what we assumed. We initially decided to test it only with 2x traffic or 3x traffic, but this you're seeing 6x traffic. When you see 7x or 8x on a specific transaction which you are not expecting or which you haven't taken into consideration in design aspects, so it is going to consume all the resources, which will also kill the other transactions from passing with the expected SLAs. So when I'm talking about the fix here, you need to model the arrival rate, you need to have think time, you need to have burst traffic. So because arrival rate, increase in arrival rate will break the system definitely, but it is not the user count all the time. Just increasing the users, no. I'll tell you what is arrival rate later. Okay. And coming to the basics, I'll tell you what is capacity planning and scaling. I'll also give you how to do insights on how to do efficient scaling and capacity planning process, how to do it. Okay. Because if you have a performance testing environment, right? I can bet on many of you that you don't even know that whether it is a single threaded component or multi-threaded component because it is not about the technical aspects. You don't get that permissions to see what is inside your system, what is there inside your system. Example is a database. Even if it is a performance testing environment database, as a performance engineer today, you will not have access to take multiple ADDM report, a single ADDM or AWR or ASH report to understand what's happening inside my database when a test is running for 2 hours, for the last 2 hours. It could be because of their policies, it could be because of the sensitivity of the application, it could be because of other security breaches if you're working with a very sensitive banking application. You cannot do anything here. But if there is an application where you're getting all the permissions, where you have to do everything in every phase of performance engineering life cycle, it's your luck. Okay. So here, uh, there are some applications where some teams to improvise the performance. to do the capacity planning and scaling. They will introduce stateless design. I'll tell you what it is in the upcoming sessions. We'll also talk about how horizontal scaling and vertical scaling will help capacity planning or scaling, because many people say that horizontal scaling gives us a bad architecture, which is not that good as vertical. But again, you need to understand why that statement is true, or why people have passed that statement, right? And also, we will talk about in-depth system analysis. Still, people are stuck about not able to come into a conclusion. What I have to do when my CPU is very high, when my CPU is continuously busy, or my throughput is flat, right? People, most of us, we don't talk about the excessive logging. Excessive logging, if you have, right? If you're logging everything on a specific application server and database server, your CPU is continuously busy. Simple logic. For that, what you have to do? You have to disable explicit logging. You have to log whatever is required, right? Just a minute. Okay. So excessive logging, your CPU is continuously busy. How many of you know what is context switching? Or let's say, I'll ask you a simple question, because it's the one side discussion that is happening. So I want to make you interactive for a while, because it's been almost 30 minutes I have been talking. So now tell me, CPU is 90% utilized. How do you debug it? What metrics you see? Anybody?
Resource monitor is one of the option,
Mhm.
and we can also go to task manager and verify there in high level.
Do you know what is percentage processor total?
We can set up this monitor. We can set up that process and configure it.
This is my configuration. Okay, this is my CPU utilization. If you see here, I'll talk about this later. You have threads, processes, utilization is not consistent. You have some average value here. Okay. Now, if you see this one, you have a base speed, threads, you have cores, and logical process. I don't know how we'll talk about that. If 8 cores, it is not 6 logical process. Even if you have 6 cores, you'll have 14 logical process. Something maybe there is some math for that. I'll tell you how they are defined later. Now, if you see the resource monitor here, okay, in the resource monitor, if you go to CPU, each of the Zoom is the current application that I'm currently using. It has some process ID, and it is running with 96 threads, which is the highest. Not highest. There is another thing like resource perfmon.exe, which is sorry, this one 307 NT kernel system, right? 307 is NT kernel and system operating system running with so and so threads, and each of the CPU utilization you are getting and average CPU you are getting. And there are some services when your application, right? When you are running an application, there could be some problematic services where a specific service could eat all your available CPU, or 25% of the CPU, or 30, 40, 50% of the CPU. You need to find out that service and you have to kill it or end it if that is not associated with your application. And if it is not doing anything on your application when it is running, you also need to do that. What are all the other services that are impacting my application server CPU? If your application server is a shared application server where you have multiple applications deployed there, you also need to figure out whether this application server CPU is because of my application alone, or is it because of a specific service which is not from the application, not from your application or from other application. And you also need to find out what is the exact CPU utilization of your application that is running in the load test for that historical time frame. Now, if you see, you have seen four cores, 8 logical process. This is service CPU usage. CPU 0, CPU 1, CPU 2, CPU 3, CPU 4, 5, 6, 7. 0 to 7 are the 8 logical processors that you are seeing. This one. CPU 0, CPU 1. I'm sorry. From CPU 0 to CPU 1. Every logical processor you see something in green in color. Let's say if your CPU is getting low, one of the logical processor you're seeing it as blank, which means that one of the logical processor is not working. One typical reason can be, it could be because of what? Hardware failure. That is one reason, okay? Now, this is one thing for your understanding, I told you, but percentage processor time, okay? Percentage processor time, you have, you select here, right? This is my local computer. If you see the processor, percentage processor time total. Where is this one? Processor information. Processor performance.
That's here.
No, that's processor information. Let me tell you. Percentage processor time, right? Let's say this is total. You know what is total? We are talking about CPU 0 to 7. These are all 7 logical processors. For example, if you want to talk only about CPU processor time 0, I'm only worried about the first logical processor. I want to see the performance of that. You can add that one. When you see total, right? All instances, total is adding all the 8 logical processors, 4 cores, 8 logical processors. Privilege time, idle time, then user time. These are all the different metrics where you can, I'll tell you later what are that. We'll not spend time here. So I'll tell you how to do in-depth system analysis, reasons for high CPU, low CPU, then Linux performance monitoring. As you have 80% of the servers now sitting on Red Hat Enterprise Linux, RHEL 8, CentOS, and Ubuntu, you need to install some Oracle VirtualBox, then bring your ISO image here, and you can do your own practice on some 140 commands on Linux, which would be more than sufficient for a performance engineer. Okay. I'll also tell you how to take reports on that. And coming to the JVM architecture, I already explained you, right? I have talked, I have spoke about JVM memory management, heap, stack, then GC, then thread dump analysis, heap dump analysis are the main areas that we are trying to focus. And again, please remember, if you know Java or if you know .NET, it would be a very advanced level of analyzing heap dumps, explaining heap dumps, how to analyze heap dumps, how to get into conclusion. All that will be discussed only from the performance testing and engineering point of view. Because if you want to understand the object creation rate, if you want to make changes in the code, that is directly a developer story, which many of the interview panelists don't understand. If you know the complete Java, you are a core Java developer. If you are working on a Java application, if you are in the same way working on .NET, identifying all the real .NET performance problems from the code level, you need to have knowledge and experience in .NET development. Same thing applies to Python. Same thing to applies to any language that you choose as your model to develop an application, right? So when I say JVM, heap memory, and all of that, what I want to discuss mainly here is I want to talk about the case studies. Simple example case study. Someone is asking you, I'm seeing a full GC every 5 minutes. What could be the reason? From a performance point of view, from my experience, I'll tell them that it could be because of large object allocation, where I have to see how GCs are happening, minor GCs, major GCs, and full GCs happening. What is the GC past time? How frequently the stop the world events are happening? Uh, how my heap areas are sized, configured. Let's say your young generation, old generation has to be given some limits, right? Hyphen XMS and hyphen XMX, hyphen XMN. These are all the JVM flags. So when you do that, how do you define this amount of memory is okay for young generation? This amount, again in young generation, this amount of memory, I can define it for uh, Eden space, or I can give it for survivor space. How do you define that? So every time I'm getting a memory leak or out of memory error, what is that you did? When I asked this question to many people in many of the interviews, they said I increased my heap memory. So increasing the heap memory, is it fixing the performance? Yes or no? You're increasing your heap memory for 4 GB to 8 GB now. You're not getting out of memory error.
Will get also.
If you with 4 GB, you're getting out of memory error in 1 hour if you're running a 4 hours test. With 8 GB, you will get the same out of memory error in 2 hours. You're postponing the error. You're not fixing the performance problem here. So this is where our course comes into picture. When you get some problem statement like that, how do you need to answer that? Even if you don't it, no one is bothered about that. But how you need to give your solution to the interview panelist is what matters here. That is where our program came into picture. This will be more focusing on making you people industry ready and interview ready. Okay. So and also heap resizing, GC tuning, all these things will be all these things will be a part of day-wise sessions. And coming to threads, right? I'll also tell you how to take multiple thread dumps. I'll explain you how to increase the connection pool, thread pool, what to do when threads are blocked, threads are waiting. So there are different case studies, understanding the difference between deadlock and resource contention. Okay, how threads lock objects, how to identify that. So all of that we are going to talk. And day 13, we'll talk about JVM monitoring, heap dump analysis, thread dump analysis, GC log analysis, and most importantly, understanding the GC algorithms like serial, parallel, PMS. Then you have garbage first, which is G1 GC, Shenandoah GC, uh, ZGC, and Epsilon GC. These are all the new GC collectors, okay? Because if you have a question why I need to understand all of these things, some 3 years back, I have recently come across one of the scenario where I have to test and measure my JVM performance with different GC algorithms. Okay, there is one GC collector called which is no GC collector. So which means that I'm not sure about that GC. We'll talk about that. That particular GC collector will not have any GC. So the object allocation will happen, the memory consumption will happen, and at the end, it will give you an out of memory error. So you know why this particular GC algorithm was designed? To know the memory footprints of the application. If you're using 10,000 users for 1 hour test, how many objects are created? What amount of memory is allocated? at what point the memory is completely full, the heap memory is completely full and throwing out of memory error. But the basic functioning of the application server, you have many objects that are being collected, allocated, that comes into heap. Then they are destroyed depending upon the reference, depending upon the reachability, reachable object, unreachable object, holding a reference. Different terminologies. Subject remains same. The GC will identify which object is not being referenced and it is going to pick it and it is going to destroy that object. So for every GC algorithm, continuous GCs will happen. The memory allocation will happen. Thousands of objects come in. Memory allocation will happen. GC will parallelly run, and it is going to destroy the unreferenced objects. But there is a specific GC algorithm where there is no GC at all. Okay, there is no GC. With whatever the number of things that comes in, it will calculate the space, it will occupy the complete memory. If there is a saturation point, it will break there and it will throw the out of memory error. You are measuring the time with how many number of users, how many number of requests, when my memory is full. That is the agenda here. Okay. So these things will be taught, reducing object creation, preventing memory leaks. I'll talk about how you have to use data structures. I mean, not you, how you have to understand whether there is a good code, bad code, how profiling will help you. Okay. So I'm going to talk about all of that. And coming to JVM monitoring tools, I'm going to talk about JMC, JProfiler, YourKit Profiler. I'll tell you how ways to take heap dump, ways to take thread dump, how to analyze that, open source tools, commercial tools, GC patterns, and all the case studies will be taught. And the main area that I'll focus here on how to do heap dump, how to take thread dump, and how to analyze a GC log. Okay. From here, how to analyze the bottlenecks and how these bottlenecks are related to the other components and other areas of your infrastructure and environment, how to correlate them and how to compare them and how to write a fix for that. So we have a detailed case study for multiple heap dumps and thread dumps for different applications. So we'll give you all of that. And talking about JVM advanced tuning, right? Uh, I'll tell you about how to detect a deadlock, how to detect a resource contention, how to identify that through thread dump, how to identify out of memory error or a memory leak through heap dump. And in the advanced tuning, I'll talk about a case study where a specific GC algorithm reduced latency by 60%. Okay, from the use case that I have explained, right? So I'm going to talk about that. And coming to .NET performance engineering, uh, before that, I would like to talk about the containerization part, serverless computing, machine learning. These are all the emerging technologies that are shaping the Java JVM optimization. Like I said, you'll have so many articles, so many things that are published, that are proved, that have come up with documentations. But you have to uh, interpret them with your experience. So if you take the classic example of Amazon Prime, earlier it was monolithic. It moved to microservices. The performance has been completely gone. Now again they rolled back everything to monolithic. Performance was good. It's not that you are using Docker Kubernetes, it is going to give you the best performance. No. You are using, instead of physical servers on premise, you are going with cloud. It is improving the performance. No. The highest latency issues are experienced from the cloud environments. Even if you use Amazon, if you use Azure, you go with the number one provider. Somewhere because of the configuration issue, feasibility issue, technology issue, or it could be because of various other reasons. It's not just because the AWS. There are so many things that will communicate, talk, and establish the connection. When all these things come into sync, right? They work differently. That's where you need to uh, identify where is the problem, right? So that way, CACD is optimizing the performance. How many of you say yes for this one? Do we really optimize performance in CACD? I mean, the statement says that if you incorporate CACD into your performance testing, this optimization is seamless because it is having some continuous integration and continuous deployment process. Is it true?
Indirectly.
Okay. Yeah. We'll talk about all of that. And .NET, like I said, right? Performance issues, performance problems changes with the technology that you work. Sometimes there will be no option left for performance engineers just apart from just to test and publish the result. But here, when you work with an application for more than 6 months or 1 year, right? It is again where we need to adopt, learn something on that technology aspect. We like Java JVM. We are talking about JVM diagnosis, JVM problems. Now we are talking about .NET performance basics. Like JVM in Java, you have .NET, you have CLR in .NET, which is Common Language Runtime, which is an execution engine for running the Java source, sorry, running the .NET source code developed in Visual Studio IDE. Python, you have PVM, parent-based virtual machine, right, which is an execution engine that runs the Python code. You're writing it when you execute it. How it is getting executed is the question. How does it work? So we'll talk about architectural internals, .NET metrics like minor GC, major GC, and full GC. You have generation 0, generation 1, and generation 2 collections here in .NET. Like young generation and old generation in .NET, you have SOH and LOH, which is nothing but small object heap and large object heap. In .NET Basics, I'm going to talk about a case study, which is LOH fragmentation, which will give you understanding on .NET memory analysis, memory related problems. And I'll also talk about some good profiling tools here, how to profile the code and how to identify the hotspots in the .NET source code. We have a sample applications for that. And coming to .NET Advanced Tuning, I'll give a separate case study here where you can work with IAS application pool misconfiguration. Okay. So I don't know if I still have this one or not. This is nothing but IAS server. Okay. So you have an application pool here. This is my application. If you go to advanced settings, right, you have queue length. You have some settings here, right? I'll tell you how to do the settings. If your application server is down for any reason, if your application server is not running, okay, your application server, if I stop this, right, your application server is stopped. If you start this, your application server is started. So that is why you need to have more permissions to access multiple web servers, app servers, and database servers. Even if you go today, if you stop this application pool, the application pool that you have inside your application server, if that is stopped, the requests are not passed. Okay, so that is what you have to understand. And day 18, I'll talk more on the real-time issues. Okay, because uh, simple thing, nighttime performance drop of a specific application. It runs well in the daytime. It could be because of bad jobs, or it could be because of index rebuilds on the database. All of that. I'm going to talk about all the real-time performance issues, patterns, network-related problems, server-related problems with case studies and all. So we are mostly close. The different problems that we see from the performance front are mostly because of the gaps that you may have. Okay, you may have, you may not have sufficient monitoring. Your goals are not clear. Your performance testing process is not clear. Your resources utilization is not up to the mark. For that, what you have to do is you have to benchmark your metrics. You have to assess delays in network. You have to predict from different areas like what could be the response time, what could be my throughput, what could be my resource utilizations, what should be my error rate, all of that, and we have to work on different directions to get things right. Okay. So day 19, I'm going to talk about best practices. Day 20, this is most important. We are dealing with some multiple databases here. Okay. Like primarily Oracle and MySQL database. Okay. For the Java applications, performance testing, performance engineering. And .NET, I'm going to talk about MySQL. MySQL database, I'll tell you how to identify slow running query, how to uh, analyze the performance bottlenecks from the different databases. I'm sorry. Let's, in one word, it's a database deep dive. Uh, like log contention from a missing commit is one case study. And I'll talk about AWR, ASH, ADDM reports. I'll tell you how to optimize a query, how to analyze AWR report. Again, AWR report sometimes, right, it will be 30 to 60 pages, sometimes 140 pages. It is not necessarily that as a performance engineer, you have to read it line by line and tell what's happening inside the database when a load test is executed. No, there is a performance point. I'll tell you the memory areas, how things will happen, what are the chances, what are the problems, what is that best that you can do as a performance engineer. The performance problems caused by environment, database, SQL queries, system global area, program global area, buffer cache. I'll also explain you the additional privileges that you have from the database point. Okay. We have multiple case studies, lab assignments will make you to create your own lab setup. I'll tell you how to install each database. One database at a time is what you have to do. Because if you're installing all the databases, you cannot use the system anymore. Okay. So the last one could be I would explain client-side performance engineering with the importance of front-end performance, common performance problems. Different tools are there, web-based test, Lighthouse, GTmetrix, Catchpoint, so many things are there. But the best tool is like DevTools, Chrome DevTools. You have the developer tools available for every browser. It is an open source utility which will give you very, very good insights. And this is how I am trying to give my best in 22 days because I want to keep that short and I want to keep it simple for you. It should help you in some way. Monitoring tools, I'm going to tell you mostly Site 24x7, you really can Datadog. It is again on the flow, okay? It's not specially focused on it's not a separate content with the use cases that we travel, right? I'm going to tell you how we are using these monitoring tools. As we have a dedicated lab setup, we are going to show you all of that. And I told you, right? The end result of this course is again, I want to help you in landing a good job. When it's a good job, to me, it's culture and deserving what you get. For 10 years, you have some number in your mind, right? My thing is like you should get that. Okay. Above that is excellent. But when you think of your skills, when you think of your experience, okay, I should be paid like this. That is where uh, we prepared this course, and this course will help in that context. Not only that, you get some good hands-on exercises. You'll get exposure to multiple case studies, and most importantly, some interactive sessions. If you have too many questions, or if you have too many things that you want to know, the more you are interactive, the more insights you'll get, the more case studies you'll learn. Okay. And you can ask me any questions. And thanks a lot. Thanks for joining. Let me stop the recording. Thanks again for your time. Nice meeting you all. Thanks. Good day.